want to thank everybody for taking time out of their very busy schedules to go over some very basic concepts of conservation planning in an attempt to probably give more tools to all of us in regards to the changes to T's and K's and conservation planning when it does get to be a bit challenging. So today I will go down through PowerPoints. Terry Kelly, the agronomist here, is with me as well. So we are going to go through some very basic concepts. We're going to actually walk you through some trainings that take a significant amount of time, but at the end of today, we definitely will have time for open dialogue, questions, and answers, because I know that we will not cover everything, so you will have an opportunity to ask questions at the end. So the first thing I want to do again is thank you, and as you're going down through this PowerPoint, jot down your questions and we will cover them. Conservation, can everyone hear me before we get started? Are we doing okay on the volume? I'm assuming so. Okay. Haven't heard no. So conservation planning, what I want to say about that is what we're going to be talking about is what is NRCS talking about when they talk about what we have to do to meet resource needs, what we have to have for conservation planning when it comes to soil loss and erosion control, and how it directly relates to 590. So we're going to cover a little bit of NRCS style, but it just so you kind of get the background of what some of the things we were talking about when we met with you earlier this spring. The objectives for today are, number one, look at planning ideas and solutions to the challenges that we have when T's drop, when K's increase, so we know what we can offer as possible solutions to those kind of challenges and how to address it with the landowners. We're going to look at understanding resource concerns. So what does that even mean? And what are the steps when we talk about planning with our clients? What are we talking about? We're going to look at what options are out there. What is it that I can offer as a planner? How do I handle the changes that have just hit the farmers that I'm working with? And it's going to be a focus on sustainability and resource management. So that is the objective. And in a nutshell, we have a 9-step planning process for NRCS. I've been asked by a few of you, how do I get my hands on that? That information is readily available. It's called the National Planning Procedures Handbook. It will go into any detail you want on what the expectations are for NRCS planning. So if you just Google NPPH NRCS, you will get this floating up. And basically speaking, we just have 9 steps. It makes perfect sense. The first thing we have to do is spend enough time identifying the resource concern to figure out what the real problem is. Because sometimes landowners come to us wanting to fix. We have to stop long enough to look at what caused that problem to begin with. And sometimes what we're looking at the bottom of the hill is not really what the problem is. So we want to spend some time talking about how do we know what the real problem is, and we'll go through that real quick. And then it just kind of steps you through some of the other parts of the planning process, which is looking at the inventory, talking with the landowner, what are their objectives. It's not about us, it's about what they want to accommodate on their farmstead. And then trying to mesh all of that together to come up with a good solution to the problem, and then make some decisions, implement the plan, and then most importantly figure out if we did indeed fix the resource concerns. So when you hear us talking about the planning process, these are the steps for NRCS by policy, what our planning process is. So when we identify problems, we look 3 ways. We look at the land itself, what's going on out there. What's causing it? What are the issues? What are the resource concerns? What does it look like today? How bad is it? And what do we want it to look like in the future? Then we look at the producer and what they want to do. Not doing anything is certainly an option. We are a voluntary agency, so we always leave that on the table as an option. So the producer will determine which of all these solutions that we propose they will handle. And then there's the planner side of this, which is how do I even know what to offer them? So we're going to get into some of that today as well. Okay. So we talked to you a little bit about documentation. This is some of NRCS's documentation. It's basically what is it I'm seeing, what are the benchmark conditions, what define that problem, and then move on, what are the client's objectives, what do they want to get out of this. So that's all I'm going to say about that. It's a pretty complex system, but again, we're just trying to get through the basics of conservation planning when we talk about documentation. So a lot of us need to know what are resource concerns, and the agency NRCS actually identifies resource concerns. There are 7 of them. We call it SWAPA. You've probably heard us talk that way. It's soil, it's water, it's air, it's plants, it's animals, it's energy, and it's humans. And the specific resource concerns in the National Planning Procedures Handbook are very clear. It's soil erosion. We've got problems with soil erosion. It's sheet and rill, or it's concentrated flow. We have degraded plant condition. We have soil quality degradation. This page is really important to you because these are the concerns, the resource concerns that NRCS's programs all evolve around. It's what our planning procedures all evolve around. You probably want to get familiar with, you need to get familiar with these resource concerns because these are the things that we want described when we're doing conservation planning. Usually on conservation cropland, we're looking at soil erosion. That doesn't mean we wouldn't also be looking at degraded plant condition because we could have issues, compaction, a few other things that would cause plant condition to be a concern. So there may be multiple concerns here that are relevant. Water quality could be a concern and will be a concern. So I just want you to be familiar with what the resource concerns are that we identify. Okay. Go ahead, Terry.
Just to add to what Judy said, so you can find the Wisconsin planning criteria to treat the resource concerns in Section 3. As a comment, as a side note, that we have 31 resource concerns combined. However, when you go to that document, you will find that 1/3 a means of assessment is based on the planner and client's observation. However, that being said, this is an evolving process. Tools are being developed, and they will continue to be developed. And as technology increases or gets more prevalent, we will fine-tune that document for planners.
Okay. And Terry mentioned Section 3. He's talking about the Field Office Technical Guide. The electronic Field Office Technical Guide is basically everything that we consider standards and spec as an agency. So that's where he was referring. Okay, so the first thing we have to do is really look at soil erosion prediction. So basically we're looking at 6 concepts, excuse me. The first one is, what is a significant planting area for the field? And a number of you have asked me, so what do I look at and which soil unit represents the planning criteria for this field? We're going to concentrate on that a little bit today, actually quite a bit, because that's really an essential part of it. And now that soils are changing in some of your areas, it becomes critical that we look at that and see if there's anything we can do and what are all the concepts of planning that we can consider when we're picking that significant planting area. So there are some tricks to the trade as far as how we address that. What we can't do is say, that one's too hard, I'm not dealing with that soil, I'm going to pick a different one. That is absolutely not an adequate way of dealing with the issue. So I just want to be really clear on that. But there are ways of addressing it on a whole field system so that those really serious restrictions can be dealt with separately if the entire field doesn't contain those restrictions. So we're going to talk a little bit more about that in a minute. We look at, go back, Terry. I want to spend quite a bit of time on this slide because these are the concepts that are really important. Steepness and length of slopes are given, and you can't change that. The only way to change that is with a terrace, but terraces are generally on those shallow soils not an option because you wouldn't have enough soil there to begin with to build a terrace. So your length and steepness are pretty much controlled. You can't adjust them. They're given. Crops grown in sequence of crops, meaning your rotation and your tillage, are really the main thing that you get to play with. And that takes a lot of management change with your clients. Crop yields have to be realistic, and they're based on that farm and that particular soil unit, so those are somewhat restrictive too. Not a lot can change there, and what does change is up to the management of that client as well. Your soil types are given, they're set, they don't change, and that's what's causing us our biggest challenge right now. And the supporting practices, where they fit and where they're appropriate, may be the secret to helping ease some of this pain in planning restriction. Okay, so what are some of the eroding factors? What's in the SNAP Plus / Russell II database? Again, it's climate, it's topography, the LNS. The climate is a rainfall factor, those are given. Topography is given. The soil erodibility criteria, the K factor, is a given. The only thing that we can adjust are the C factors, which again are crops and tillage methods. And then supporting practices oftentimes are another means for us to adjust. And I will talk quite a bit about supporting practices as well. Okay. All right. So I'm going to just cut to the chase. This is an exaggerated situation. I'm hopeful that none of us have had to deal with a farm that looks like this one. I'll blame this one on Iowa and just say that I went over there and grabbed a slide, even though they're doing tremendous things, so I probably can't say that. But I will tell you that this is absolutely possible, so I want to show you this slide because we always use this slide for Russell II purposes, because Russell II only looks at sheet and rill erosion. So when you start to see ephemerals and classic gully erosion, you no longer can be using Russell II because it's telling you it's too advanced and it's not working. So we've got real issues if it gets to this stage. So what I'm asking you to do is when you are out in the field, really take a good observation of what you're seeing, because that sometimes can impact the soil planning decisions that are made, and this is called benchmark condition. So in this case, I would be extremely conservative on what soil unit I would use on a site like this. I would make certain that the landowner fully understands what's going on here as far as the rills are concerned. They're telling him something. The gullies often get blamed on a rain event, and unfortunately that may be true, but generally speaking, when you've got uplands that are looking like that, rain event is not the reason that this is created. So just always be looking at what it is you're actually seeing when you're on the land, when you're describing that benchmark condition. Okay. I want to talk quite a bit about the significant planning area. In fact, there is a document put together that's called the dominant critical slope, and this is a real big piece of the pie as far as what soil unit would I be using to define this field. This field is a typical field. It's got a lot of variance. It has a 250-foot slope, 4%, that covers 40% of it. So I hate using this slide because it's in such bad condition that but you may have slides where they're actually farming it, it's not eroding to this degree, and you're looking at it saying, what can I do? Maybe 10% of it is 12%. And there's 60% of it that's 4% or 2%. And do I have to use that slope that's so restrictive? And the answer to that is absolutely not. we're hopeful that you are going to be looking at these as different units. So those are some ways that you can deal with this. We want to make sure that the unit you're using, if it can be isolated and it can be farmed differently than the rest, then that would be the best thing that you can do. It'll be very unfortunate, and I know that it's the case, that some of this is going to be, the T's are dropping, and even the 4% 250 may be a critical issue to get it. And we will talk about some other things that you may want to consider there. This one we put up always for dominant critical, which is which unit do I use? And I will say that the 8% 200 on a site like this one is the one that definitely you should be considering using, only because things are so bad, nothing is being treated at all, and you need to be very conservative because you already know you've got some major resource concerns going on here. If this was all treated and the field looked like it didn't have these issues, they had a waterway in place, the rills weren't there, you could definitely argue that 6% 200 foot would be more appropriate representative of this whole unit. We like to have the representative field area of that field chosen somewhere between 20 and 30% of that field is generally what usually falls out when it's being treated. The exception to that, what you have been told, and I totally concur, is anything over 10% of that field is fair game. So if you're looking at a soil unit to use, you have to ask yourself, do I have any serious conservation risks where I have to pay attention to a soil that's 10% or more of that field? And in this case, if I had one that was even 15% and it was 8% 200, I'd be using that, because you have so many associated risks with the amount of runoff that's going here. So that concept's really hard because we try to put it into defined, it's always going to be this, but conservation planning has to come in, be factored into this. What are the resource risks? And you always have to use that as justification for which choice you're making. This is very oversimplified because we have K's and T's and we haven't even talked about that, but I just want to give you that general concept of what is conservation planning and how does that enter into this decision.
And so just to echo what Judy said, when we look at that planning area, we have to consider the planning area next to the environmentally sensitive area. So we may plan and be more or less lax on a field that may be closer to an environmental sensitive area. We need to consider the assessment on those areas that perhaps are a higher or have a higher sediment delivery rate. So those things need to be seriously considered when we talk about the significance of the planning area.
And I know I've taken some questions too, and I think they're excellent questions where, you know, somebody will ask, well, I have 15% of the field that's pretty erosive and it's really close to surface water. What can I do because 85% of the field is totally under control and not as steep as that portion? That's where splitting that out, doing something different with that unit makes all the sense in the world. So you can't ignore that unit because it is a high risk and it's contributing to a serious resource concern, but there are ways that you can treat it separate than you would the rest of that field. So, and we'll get more into that in a minute here. So here again, I just wanted to re-emphasize, it's the same photo, but I just cannot express enough all the years of planning I've done. It's really hard for a landowner to come to terms with sheet and rill erosion, and if they have significant rill, things are not going well. If you've got a lot of sediment dropping out, things are not going well. Those are symbols that our erosion is not in check and it's not sustainable over time. So what I want to say is oftentimes you're not going to get that feeling when you're driving across on big flotation tires. You're going to get that feel when you're driving across in a small tired truck, or better yet, walking across there. So I ask that we always be looking at that, because those are indicators that we do indeed have more erosion than what we commonly think. And we talk about 100-year storm events in very unique situations. And yes, those can really blow us up. Those are very small, localized areas, generally speaking. They're not even usually a whole county. They're a part of a county. But when that hits, that definitely shows you who's got the right conservation in place and who is struggling. And so just saying it was a 100-year storm event and he doesn't usually have that problem, I think we need to rethink that and make sure that everything's in check as far as conservation practices go. Okay. All right, let's keep going. All right, so I just want to say a few things here about these slides. The top left-hand corner is basically talking about sediment delivery. And while it looks like everything's just fine and going well on the uplands, I would really look at the uplands as the culprit for a lot of the outlets. That sediment is coming from somewhere, and we need to be very attuned to what it is we're seeing and talk about slowing water down way up on top and where that sediment is coming from. The same as the second picture. The second picture at the top right hand kind of suggesting that, do we have a compaction issue? I think we definitely have an infiltration issue. Water's not going in, it's running off. It's running off at a high speed. We usually are going to see that on saturated conditions with heavy rain events, but these two are indicators what's going on with soil health, what's going on with soil infiltration rate, what's going on with the ability for that field to slow that water down before it leaves. You're definitely seeing a problem here. The lower left-hand corner is a great indicator. You've got crop signatures that say, all right, we have lost some topsoil on the top of that bluff there, or the top of that crown of that hill. So what do we have going on there? And then again, on the lower right-hand side, again, we're dealing with tremendous sedimentation and runoff channeling. Okay. So solutions when planning gets difficult. I don't have magic answers, but I'm going to throw out a whole lot of potential solutions, talk about them, and then we'll have some time at the end to talk. The soil unit that I use, we just talked about it. There's more information on what critical dominance in soil is, what unit is appropriate to use. Split the fields up, we talked about that. Buffer systems really do a tremendous good as far as slowing water down, and they're an easy, quick fix. We'll talk about that, where they fit. You got to have a little bit of contour for those to work. Tillage and rotation we'll talk about. Cover crops are another opportunity that we may or may not feel would resolve things, but Terry will show you some examples with covers and what they could potentially do. Terraces I don't feel real good about, because your 1T, 2T soils, you don't have enough soil to begin with. Terraces are designed for fields that have a lot of soil to begin with. CRP is definitely an option. We'll talk a little bit more about that. Continuous practices would be an option, where you just take little bits and pieces out and enroll it in set aside of CRP program. More grass in the rotation, and then there's other creative avenues that maybe you never know what a landowner is thinking. If there's other options for some of those really fragile lands, then maybe throw some of those options in their direction as well to consider. Okay. So this is just one of those pictures. What would I say about that? I hope that what you would say here is, oh, the uplands need treatment here. So what we're hoping that you would say is, don't have a whole lot of residue going on, and we definitely need to slow some water down way up on top, because it's starting to channelize pretty good when that grade changes. So those are the kind of things that we hope you would be thinking. This one, all appearances are it would lay out really well for a contour system or a contour buffer system. Those are some choices, but residue is really screaming at us as well. There's virtually no residue here. So NRCS looks for economically viable choices, agronomically sound choices, environmentally friendly choices. So we don't want to see the wrong thing being prescribed. We need to make sure we are looking at economics, agronomy, and resource concerns, all three in one, okay? C factors, just real quick, canopy, C factors, what can I do to put more residue on the surface? Our most popular thing right now is cover crops because it is an instant solution to some of these problems. Given that, you need to know what you're doing when you put cover crops out there or you can hurt yourself too. So, but that is one that is getting very, very popular. Historically, if you put covers out and do a lot of tillage to do it, you're going backwards. So these are just some concepts to keep in mind. Okay. And another concept along the way is how do I get more residue on the surface to protect from that rainfall impact? Okay, I'll keep flying through these. So continuous no-till is an option that we have definitely encouraged on some of these tough sites for a lot of years. But just like everything, if you don't do no-tillage correctly, that's a disaster in the making as well. So our definition of no-tillage, in order to see the full impact of a positive no-tillage, is between 3 and 7 years before that soil actually makes it back to the full benefit of no-tillage. So you will see some negative impact at the front side of trying no-till. We got some serious concerns with equipment and a few other things, but that is definitely something that always helps us reduce that erosion concern. Okay. So, and we don't have to talk too much about why that works that way, but here's examples that you've seen everywhere for 25 years. Runoff is definitely reduced from no tillage. All right. And the more cover we get on the surface, the more protection we have, and that goes without saying. Okay. So cover crops, this is the benefit of cover crops. We can go on and on about that. There are some negative sides of cover crops, and if they're not managed correctly, that will impact negatively. But cover crops are a very good way of addressing some erosion concerns. Okay. We're going to go quite quickly through these, so but these slides are available anytime, so keep going, Terry. Field borders are another way. If you've got a field edge that's causing erosion concerns, encouraging a field border, you can put that into CRP. That's just a very narrow edging that you get out of production. You put it into grass so you slow the water down as it's coming or going from that field, and it's trapping sediment as we go. Okay, keep going. And these are some more field edgings that were put in play. Some of those photos are mighty old. Grass waterway is definitely a concern too. When you do have that water flowing off, you got to do that safely. So grass waterways. And then the other practices, and I know a lot of people say these are practices from the past. Well, strip cropping doesn't have to be, but if it fits, that's a good tool yet. And the one that I think we need to really consider are contour buffer strips. Contour buffer strips are a minimum of 15 foot of grass, breaking the slope in half, and it slows that water down significantly. So we are looking at that as a possibility. Going across to 40 with a 15-foot strip periodically on the sharpest point of that hill doesn't generally take a lot of land out of row crop production. So that's one of the reasons that those are very beneficial to consider.
And just consider that the contour buffer strip really is one of the cover types that are available in CRP. Yep. And the producer will get a rental rate. One of the disadvantages is they cannot harvest the contour buffer strip versus receiving an incentive payment through EQIP, where they can harvest the buffer strips if soil loss is not compromised from the harvesting.
Okay. Good point. Thank you. This is just a terrace. Again, terraces are great. They chop that slope length up, slow that water down, and they stop that water, but they don't fit. So do not encourage them if there isn't significant amount of soil out there to build them with. Okay. And then this is a bad example of a filter that just needs to be a field that needs that filter strip along that water. Okay. So we have riparian buffers. Those are trees planted along. We have some tremendous programs that help cost share that. There are filter strips, programs that help with that. And then, of course, grass waterways. And EQIP pays to repair problems. That's what we do, is repair problems. There are additional practices that can help resolve resource issues. There might be a well that from the nutrient management side is concerning that needs to be closed. We could have runoff from roofs that if we keep that clean water clean, then our concerns go away. We have clean water diversions where we can actually take water above a barnyard and keep it clean, and that helps reduce the impact of that barnyard. So these are just some ideas. And we also have a CFP program where if you're already handling your resource concerns, you can do additional rewarding environmental enhancements. So we have two programs that possibly could be beneficial to landowners. Okay. So Terry's going to run a real quick scenario here with his, he ran some some conservation practices in Russell 2. So I'm going to turn it over to Terry at this point to talk about some possible scenarios that he's put together.
As Judy stated, she asked me to give an example of progressive planning, the process, and really the alternatives that we can offer the producer.
Might want to speak up here. There you
go. The benchmark condition, and so what I did, I looked at seven Russell 2 runs, and so the benchmark condition, I took this example. I used Dane County data out of Russell 2. And so this example is an Edmund, a silt loam, between 6 and 12% slope. But take note that that mapping unit has a T factor of 1. Okay, so we took one of those mapping units that had really severe limitations in terms of crop production. The hill slope profile was 10% at 150 feet. I had a realistic crop yield, and Judy, as she indicated, that we must have realistic yield goals when planning for Russell 2. And so that being the case, we had for corn for grain 150 bushel, and soybeans 35 bushels. But what's unique is that in order to compare apples to apples, oranges to oranges, I had to keep everything consistent, okay? So the first run, the benchmark condition is corn grain, corn strip till, no-till soybeans, and no contouring. And so I will just walk you through those examples of the Russell 2 data that was computed, okay? So hopefully everybody can see this slide. Again, run 1, we had corn for grain, strip till, 150 bushel yield, soybeans 35 bushel. And we're going up and down, none contouring. We had a soil loss on a 1T soil of 3.3. Now, however, you would say, well, you know what? Why is my conditioning index increasing? But we did have a positive conditioning index at 0.387. So it's telling us that even with that system, organic matter is trending upward, okay? We have a fairly low stir. We're 15 or less, so that means that we are contouring. I want to go to the next. I'm sorry, we are No-till. We meet the no-till standard with a 6.8 stir value. Would like to go to the second run. The second run is corn grains, strip till, soybeans. In this case, what I did, I added 12 tons of semi-solid manure. And as you see, the soil loss went down by 0.2 of a ton. We also increased our soil conditioning index to 0.4. Now, if you were to drill into the Russell 2 tracking residue file, it would show that we increased the residue by 12% by putting 12 tons of manure. The issue with the manure is that we have to convert it to percent dry matter and then convert that to pounds. The next example is number 3, run 3, and I'm going to go back up for a minute. And I want to show you run 3. We have corn grains, strip till, soybeans, no-till. Keep in mind that the yield and the crop rotation is the same. I put 12 tons of semi-solid manure on the landscape, but also I added contouring. That's practice 330, contouring to that management. And the erosion dropped to 2 tons per acre. Now, if you look in a column that say where you have the color codes, soil loss is okay. The yellow means that we are at 2 times T. And as you know, that represents an alternative system that complies. But what we're looking at is trying to progressively plan to the point that that MAP unit is sustainable in terms of crop production. Also, as we go along with that run, we did increase our soil conditioning index. And you will see that that is a common denominator, okay, as we add supporting practices to the landscape. The next run that I have is...
Terry, I'm going to just, before you leave that run, I just want to be clear that 2T, meaning twice tolerable soil loss, is not an option for nutrient management planning. Nutrient management planning, again, requires that they be at tolerable soil loss. And I just want to make that really clear. And also, I just want to clarify, I don't know how many of you work with soil conditioning index. That's something that's really, really important because, as Terry pointed out, it really shows us what is happening to the organic matter in that system. And so anything over 0, 0 means nothing's happening, it's maintaining itself. If your soil conditioning index is above 0, the higher it goes above 0, the more likely that organic matter is growing. So we always pay attention to soil conditioning index because they tell us so much, especially the soil health. We don't want to see negative numbers in soil conditioning index. So that's one of the reasons that we work with soil conditioning index.
And just to add that now with the new Russell release over a year ago, we don't have a relative row grade in contouring anymore. It's absolute grade. That's what we look at. In this case, we had 1%. And if you look at the contouring standard, we can be off by 10%. So 10% of a slope with a steepness of 10% or 10-foot fall per 100 feet is 1% row grade. So that would be the max in order to meet that standard. The next example is corn grain, 12 tons per acre of semi-solid manure. But notice that 4 rows down, we added contouring, we have a cover crop, and we have practice 332, which is contour buffer strip. And that buffer strip was put on the mid slope, right in the middle of that hill slope. And what you notice there is that that column is green. We reduced that erosion to half of T. So we're right at about a half a ton of soil loss per acre. I'm going to go back up. I just wanted to make another comment regarding that. I didn't show the run. However, when I added cover crop to run 3, it's not down below. However, the soil loss went to 1.3 tons per acre. And so when we talk about a tolerance, we should be no more than 5% over the T value. So 1.3 will not meet. We should work that number down as close to 1 or below 1 as possible. Now I'm going to go to run number 5. Okay, and so what I wanted to do was come back and use a vertical tillage tool. And Russell 2 is referred to as a soil conditioning tool. And so with the vertical tillage tool, we had a rolling basket, we had a harrow, and we had straight disc. The soil loss jumped to 2.3 tons per acre. But take note of the stir value. So the stir value was 26. So it's not really a no-till system, because when you look inside that operations file, it's going to show that 100% of the surface area is disturbed. And keep in mind that the stir ranges from 0 to 200. And so in all reality, vertical tillage tools are a good option for farmers. But when it comes to those soils that have severe limitations, in order to further reduce the soil loss, we have to use more conservative tillage options. Okay, so I just wanted to show you that. And just as a side note again, whenever we have the red, it means that with 2 times T. Yellow means within T. No, I'm sorry. We're less than 2 times T. And green means that soil should be productive year after year after year with those soil loss erosion rates.
So one of the things, as we talked about conservation planning, we just want to make sure that we're throwing out as many options as we possibly can for these producers. Terry played with tillage. So tillage is an obvious thing. We always think tillage. Rotation, we really do need to play, and I would encourage you to always have a couple of different rotations there too. They may want to do corn, beans back and forth, but we may be looking at corn 2 years, soybeans 1 year, just to get enough of that residue built, or explore that cover, or explore double cropping or something. But there are tough decisions to make, and the more options that we can throw at a producer, even though it's hard to find them, that's definitely what we want to see as far as planning is concerned. So we're at 9 o'clock, and what I like to do is I like to open things up for discussion. So I'm willing to shut her down right now. This is what I'd hope to give you, is a few ideas, a few solutions to challenges. There are no easy answers, but I wanted you to get a little better concept of what resource concerns were and know what our steps to planning were. What are some of the options? What can you offer? How do you handle the changes? I wanted you to know what it is that we hope to accomplish, which is sustainability and resource management. So the rest of the time is yours, and there are no questions that we won't entertain. So have at us. Okay.
This is Penny. Did you see the one, wasn't listening all the time, from Jen about the 10% dominant critical soil used?
No.
Yes, I'll read it.
Out loud.
Okay.
If we choose the 10% dominant critical soil used in NMP, wouldn't
Tree management planning,
wouldn't we be covered? I think Jen posed that question.
Yeah, and all I can tell you is, if you want to be way conservative and use 10% always as your bottom line, that's perfectly acceptable, because that means you're very conservative in your conservation planning and you're not making any decisions based on what you're seeing on site. So yes, of course you can plan more conservatively. No issue with that.
And keep in mind, we had a webinar. I don't see any other questions at this time. Oh. Do you have an illustration showing the different contour buffer strip options? I don't have one, but I can go into rough.
Go to my photos that I had. Let's pull up a couple of photos and talk about it.
Right here.
No, that other thing that I was going to get to, but we didn't. Where that is. I've got a couple of conservation plans and we can just talk about it. What I will tell you is the contour buffer standard is really, I think, is very helpful, and it kind of tells you exactly how to design a system. I will tell you that back in the early 2000s, when our soil updates, the other one's down, were done in the northwestern part, when I was a district conservation, it was very, very difficult because we lost all of our Seton and Fayette soils, which tended to be deep soils, valuable soils with 5-ton soil loss, and they became the silt loams that they always were, that melted like sugar in a heavy rain event, because they really, really were a problem. Yeah, okay. Oh, right where you were, only scroll down instead of that first photo, Terry. Okay. No, back to the photo. You were just there. The conservation plan photo that you were just at. There's a whole bunch of them in there. Okay. So what I will tell you is we really used contour buffers to our advantage there. We had to slow the water down. We had to do something because our soils dropped from 5 down to 3T a lot of places. And the contour buffer system was extremely popular, so that's what we used. And basically, Terry talked about cutting that slope length. You need to have a buffer for each slope length, and the practice standard will tell you that. It's not on the PowerPoint. It's the other. You just have it. It's not that. That one. It's a PDF. So, okay, I'm sorry, I didn't tell Terry where to find that. Scroll down. All right, I'm going to show you a couple of things. Well, let's go up, and I'm going to talk briefly, and I'll get to the buffers real quick. Yeah, just keep going all the way up. I talked about, here, let me, I'm going to show you a couple of examples of conservation planning. This is a farm where they had a really steep part of the field right here. It made no sense. It was an escarpment that just jumped out. So what they did is they put that little piece into CRP. The rest of the field is practically level. But they had a terrace going across there, a hillside terrace. So that's ways that you can get around it. They had wetlands, they had ponds that needed to be protected, so they threw those little pieces around them in CRP so that they could take care of that. This is one, if we can see, this is an example of a terrace system, but a buffer acts very similar to a terrace. Terraces are a little narrower, but a buffer is 15 foot. But here you have a cut in the slope across that hillside. And we have another one down here from another county that's a little steeper. So you've got a system here, and they may or may not put a 15-foot strip in a couple of locations on these contours. And those would, you know, not be part of the rotation any longer, but they definitely help tremendously. on the soil loss equation. And you can put them into CRP. The rental rates have increased significantly, so it's real easy for them to do. Or they can have them match their equipment and make hay on them. Some more. I hope that I answered that. If not, let me know.
So to add to Kurt's question, within Russell 2, he asks about illustration. Within Russell 2, we can put those contour buffer strips on the upper reach of the slope, the mid slope, and where soil deposits, the foot slope. And so there are options in which you can place that buffer strip. Also, that buffer strip can be designed to be a certain percentage of the hill slope. So if the slope is 150 feet long, we can design it to be 10% of the slope or greater, or any variable we choose as a planner. The next question. Okay.
All right, the next question, can we use Snap Plus to do the runs to provide options that would be available to get tea for our growers? Snap Plus has a lot of options. It doesn't necessarily have every option. So yes, you should be using Snap to get options, and you should be giving them different choices when you're planning with them. Russell 2, it's a little easier because we have many more options, but Snap does have options. We also had a question. You said you can go 5% over T. The answer is 10% over T. So if that was stated 5%, sorry, excuse that. The answer is 10%. So 1 T is 1.1 T. So that is the answer on that one. And so if you are splitting management for 2 parts of a single field, you can just write that in the narrative for a highly erodible conservation plan. What we generally do is we split the managements and we just outline it in the plan map that these are 2 separate units, and yes, you can do that and just define that for the landowner so they understand that you've split that field out. But it is entirely doable to split fields out, and that's what we have historically always done if it is an option that makes sense for the producer. I think that's it, but feel free to keep throwing some things at us because we want to make sure that we've answered your questions today. And I'm sure we haven't answered all of your questions. Go ahead, Terry.
I would just like to make a comment. As technology increases and we move forward with conservation planning, I attended a session in Texas the latter part of February, and the purpose of that session was to assess a tool, beta test it, and it would give us a benchmark condition, and actually it would give us some qualitative data telling us if the resource concern has been addressed. So hopefully in 2017-2018 fiscal year, that tool can be used by planners in that we can create a benchmark condition using toolkit, and it should give us some indicators of if we have reached or are addressing the resource concern above the sustainability level. It appears that this year we're going to be looking at assessing contracts that are in the National Water Quality Initiative areas, and the one that we will be working on intensively would be in Green Lake. And so just the tool will run Russell 2, have WinPST embedded in it, and WEPS. We have a wildlife habitat assessment tool that's embedded in this tool itself for us to make an assessment of soil. water quality, and wildlife habitat and nutrient management. And so we're going to see how this tool works, because it has it's not going to be as accurate as running Russell 2 or WEP firsthand.
Okay. Well, thank you so much, Terry, for helping with this. And what I do want to say in conclusion here today is it is really, really important that we work with our clients and that we always give them options. Some of those are easier to do than others, but make sure you're giving them options, letting them make decisions, because that's part of the planning process. The most important thing I also want to leave you with today is it is not unusual that soils do change over time, and it does make things a lot more challenging. There's probably additional tricks to the trade here, but I hope that what we gave you today got you thinking about some possibilities of additional things that you may want to throw out there for your clients to consider. And most importantly, I also hope that you understand that changing the soil survey happens. It's something that needs to be done because it helps us keep current with science. We do have serious concerns about making sure that soil is there for future generations and that we're not depleting it. And so that's our common denominator with our landowner. So hopefully today was helpful. And if you have additional questions on any of this information, feel free to contact Terry Kelly. As our state agronomist, he will entertain them, or you also certainly can drop me an email if you need to. So I greatly appreciate, Penny, I certainly appreciate you hosting us today. Thank you all for your time.
Thank you, everybody, and thanks, Judy and Terry. That was great. And we will be putting this on the Wisconsin Land and Water website at some time posted, so you can refer back to it. And this was also provided by this GoToMeeting by SITCOM, the State Interagency Training Committee. So I think that's it. Everybody have a great day, and we'll probably be back in a couple weeks. Thank you.